Right, what up, everybody? Today we're talking about total resistance, right? So remember, resistance is a measure of how much electrical charges are slowed down as they travel through something. In the circuits that we've been building, the most common resistor is a light bulb, although other things can be resistors, right? If you plug your computer up to a circuit, certainly your computer acts like a big resistor. If you plug in like a hair dryer, that's a big resistor. Um, So anything that you plug into a circuit that is going to slow down the flow of electricity is considered a resistor. And so an important quantity to measure is what is the total resistance, right? If you have more than one thing slowing down the flow of electricity, how do you find what is the total resistance of all that put together? And there are formulas for that, as you see on the screen now. And the formulas change um, depending on whether it's a series circuit, if it's one loop, or if it's a parallel circuit, which would be several loops. So let's see how these equations work. All right, so first of all, let's look at this circuit right here. And if you see these squiggly lines, this just represents some type of resistor. So it could be a light bulb, it could be something else. It doesn't really matter. But this resistor is 60 ohms, and this resistor is 60 ohms. So the electrical current from the battery would have to go through both of these and then come back around. What would the total resistance be? Well, this is a series circuit, and in a series circuit, you just add the two resistors together. So 60 plus 60 is equal to 120 ohms. And so having the second resistor makes the circuit have 120 ohms of resistance. So actually having two 60s, the combined effect is that there is more resistance. Let's add a third one, right? And use the equation again. 60 plus 60 plus 60 is now 180. Okay, so remember it was 120 with two resistors, now it's 180. So that means the total resistance will go up when you add more resistors in series, right? So that's why if you made a circuit with two light bulbs and then you add a third light bulb in series, you'll notice that all of the light bulbs will get dimmer because there is more there in the circuit that's pushing back against the flow of current, which means there's going to be less current going through the light bulbs. But let's look at a parallel circuit, right? So here's a parallel circuit with two 60 ohm resistors. Okay, and remember, if this was in series, it would be 120 ohms. But because it's in parallel, we have to use the other equation, right? So RT is the total resistance. R1 and R2 are the resistances of these two resistors here. Okay, in this case, the same thing, so it makes it easy to add. 160 plus 1 over 60 plus 1 over 60 is just 2 over 60, right? But notice this is not the total resistance yet. Okay, we have RT is on the bottom of this fraction, right? So in order to flip this fraction over, you'd have to flip the other side as well. And you get that the total resistance is 60 divided by 2. Or if you divide that, you get 30 ohms resistance. So this is interesting because each individual resistor is 60 ohms, which means it fights back with 60 ohms resistance. But put together, they're only 30 ohms. So actually put together, they resist the electrical current less than if there's just one of them. Now let's continue this pattern and let's just add another 60 ohm resistor, and we'll add it in parallel. And we'll do the math, and we'll see that we actually get a smaller total resistance. So it seems like the more resistors we add in parallel, the smaller the total resistance is. And that's correct. All right. Now, why is that? Think of like a long line at a supermarket trying to get out, right? Do the cashiers speed up the line or do they slow it down? Well, you'd say that they slow it down. They offer resistance, right? If they weren't there, you could just walk out the door with your things. Um, but if a second cashier opens up, the long line is cut in half and people can get out faster. So even though the cashiers themselves are slowing people down, having more of them causes people to be able to go faster because it opens up another path that they can go through. And so that's a way that parallel circuits are, right? You add more resistors in parallel, you're adding more ways that the electrical current can flow. So the electrical current is going to flow out through the battery. Some of it can go down here through this resistor, while the rest of it goes this way. And then some more of it can go down here, while the rest goes this way. So the electrical current can split up and go down multiple paths, which actually speeds up the flow of current. More current will come out of the battery because there's more paths for it to go through. All right, so in parallel, more resistors means a lower total resistance. I'll see you all in the next video.